Okay, welcome to the fifth session, where we will just learn what is the difference between the compiled language, what is machine code, what is byte code, what is the difference between compiled and interpreted language. Right. And the last session, I was discussing about what is the advantages and disadvantages of learning Python or of Python. Right. Okay. So first, we will understand. Okay, there are two, three basic computing languages are there. Suppose one is C, C++, another is Java, another is Python. We will just compare among themselves how they are getting executed internally, and then you will start from there. Okay. Okay. First thing is, what is a compiled language? What do you mean by compilation? Okay. Straight thing is, compilation means translating. Okay. Yes or no? Translating means computer doesn't understand your English language. Computer only understand its machine code and the binary hexa of that hexacode format. Right? There are certain formats are there. Only computer only understand that language. Okay. So let's first start from the C++ code, C or C++ code. How, whenever you are writing a C++ code, what happens internally? So whenever you write a C++ code in your computer screen, right? What it happens is whenever you write it and then you try to run it, what internally it does, it is just converts that C++ code, okay, into your machine code directly. There is no intermediate codes are there. Directly, it will just convert your code into the binary format, which CPU will understand that. So what it is saying that C++ is a completely compiled language. C++ directly compiles your code into the machine code. That is why it is called a compiled language. It does not need any virtual machine or interpreter to run, just a CPU that understands the compiled binary. Okay. So sample hello world C++ code if you're writing it. So whenever you try to run it or you first compile it, right? That you have to compile it first, then you have to run it. Okay. Somebody who was not able to understand how to compile and run, right? I will just show you in other example how you can compile it because Python is not a purely a compiled language. So that's the reason we don't compile first, then we run. We directly run it. Okay. So whenever you will just study, suppose you are the first time you are the learner, like you have never done any kind of coding around. So first we have to compile it. Okay. I will just give the example. Don't worry. Okay. So C++ code, what happens whenever you write the code, directly it just translates that code into the machine code. Internally, you won't see it how it is happening and all. There is no intermediate code, right? So this is the example of C++. But in case of Java, so this is a bit different. Java and Python is different. Okay. So in Java and Python, what is happening? Okay. Suppose this is your computer screen. Okay. Then this is Java code. Okay. So Java code here directly doesn't get compiled into machine code. There is an in between. That is a byte. It converts to byte code. Okay. Then byte code again either interpreted or compiled into machine code. Okay. Similarly for Python, this is a computer screen. This is a Python code. This is also internally by byte code. Then it is getting converted into machine code.
Here, what is the means of white code something?
I will tell you. Okay, so Java code directly when the format directly doesn't get converted into machine code. Python code directly don't get converted into machine code. That is the intermediate codes are there. Okay, and why it is there, I will tell you. Now you understand the difference between C++ execution, Python, and Java execution. Okay, now we will see what is bytecode and what is machine code. Bytecode means Okay, not understood by the CPU directly. So this bytecode, okay, that won't be get executed by CPU directly because CPU won't understand bytecode because bytecode is not the machine code actually. Bytecode looks like it gives you the instructions. Machine codes are something like this. Binary format. Suppose this one 01, okay, 10, something like that. But bytecode, how it looks like, I will tell you later in the later session. So why bytecode is there? Because it is a platform independent intermediate code, not understood by CPU directly, executed by virtual machine JVM per a Java per PVM per Python. Okay, looks like a low level language, but still needs further processing to run on real hardware. Okay. So for Java and Python, why bytecodes are getting generated? What is the importance of that? Java is saying that once it is compiled successfully, this bytecode, you can take it to any platform, it will run. So Java's slogan is write once, run anywhere. That means once your bytecode is the Java compilation is done successfully, you can easily just take that file, you can run it anywhere. In wherever the JVM is installed, it can be installed on Windows, Linux, wherever it is. Okay, anyone's computer, wherever JVM is there, it can run it. Okay. So what is bytecode? Bytecode is a platform independent intermediate code. Why is it intermediate code? Because Java code is not directly converting to the machine code just like C++. So this is an intermediate code. Why is it intermediate? Because this is between your code and your machine code. Not understood by CPU directly because C++ code is directly understood by your CPU or processor. But this is not directly understood by CPU. You have to convert to the machine code executed by virtual machine. So that bytecode again getting converted to machine code that is doing by a virtual machine. So for Java it is JVM, for Python it is PVM. Okay, it's a low level language. That means you can understand what it is saying, but again you because computer only understand the machine code. So your bytecode again getting converted to machine code and then it is understood by processor. What is machine code? The lowest level code. Why it is lowest level? Because computer understand the machine code only. So this is the lowest level. There is no lower than there is no lower code than this machine code. You getting my point? Fully platform dependent. Okay, what you name fully platform dependent? So C++ code is CPU. That means it creates a .exe file. Whenever it will be compiled, it will create a .exe file. But a .exe file you cannot execute it on Linux or your Mac operating system. So your machine code is actually this is always a platform dependent code. Okay, typically generated by compiled language by C or C++, stored in a binary from sequences of 0 and 1s. Okay. Any questions, Ravan?
No, sir, not now.
Very clear. Okay. No need to like overthink all the things. It's very simple. Some language is one step code, which is C++ directly converting to the machine code. But some languages are hybrid languages because directly it is not converting to the machine code, but it is converting through bytecode. Again, bytecode is converting to the machine. That is the only difference. And what is the advantages of that? Once it is converted to bytecode, you can take it to any platform, it will run. But in your C++ code, machine code only can run in a single platform. Are you getting my point? Any questions? Very simple. Okay. What is the difference between the compiled language and interpreted? Entire program translated at once into a machine code. I already told you, right? Entire program will be translated at once into machine. I already explained you last time. But in interpreted language, it will be a line by line executions. Okay. Speed obviously fast. Here it is slower. Catches all errors before running, stops execution faster. That means, okay, so once your compiled file is ready without any error, once it is error free, Then you can run it at anywhere, catches all the errors at a time. But here it will be read one by one, one by one, one by one. So if there is a error in first line, it will be stop you. It will say there is a error at one line, but it will give you all the error. Dependency, independent execution. Okay, so independent means .exe file can be only run on Windows, but here it requires an interpreter. Runtime performance, high performance. Compiled means it is high performance. I already told you what is the difference between high and low. This is bit lower performance because it is translating line by line. Platform dependent. Obviously, why I told you platform dependent? Because this is generating .exe file. So it cannot run in a other Linux or other system. But here, interpreted language are platform independent. It can run anywhere. More difficult because code is compiled. Debugging means it will at a time it will can give you 100 errors, but it is easier as code run directly with line by line because one line is giving the error, so it will tell to fix that error, then it will go to the next line. Development longer because compile run takes cycle. This is it will be run actually. Development time actually will be faster. Okay. Output is binary file. Here is no binary run source code directly. Okay, example C, C++, here Python, Java, Ruby, Perl, those are actually interpreted language. Tools used compiler is GCC, G++. So actually you need this kind of thing just to compile it. Interpreter means directly you have to run it. Okay, Python something.py, Node something.js. Okay. But the thing is, Java is both compiled and interpreted. Actually, this is a controversial question. Okay, Java is both compiled and interpreted. But actually, Java is more actually compiled actually because 90% cases it compiled both the scenes. Python also uses the bytecode plus interpreter. Here, what it is doing? Here, computer skins, okay, Java code, it is getting converted to bytecode. Again, it is machine code. So Java code is first compiled to bytecode, then bytecode is again compiled to the machine code. So this is completely a compiled language. But why it is both hybrid language, I will tell you in the upcoming slide. Computer skin here, Python code is getting compiled with the bytecode, but again, bytecode is getting interpreted line by line to the machine code. Okay, don't worry about that one. I'll just explain you in the upcoming slide. Okay, use cases, system programming, game engines, performance critical apps. It is just uses C, C++. If you are going with scripting, automation, web development, data science, okay, where speed doesn't make any sense, okay, just a 1 second, 5 second gaps also is fine. So in that case, you can go with that one. Okay. So this is I was just giving one just example, right? That day. Just
The sound is not coming.
so did you see that example? So it is line by line, it is interpreting. Are you getting my point? Okay. So how a bytecode looks like and machine code looks like. Okay. Okay. So whenever you are writing a Java code, okay, you are compiling first. How you are compiling? Suppose your code name is hello.java. Okay, so you are writing a simple out.println hello world. Public class hello, public static void main, system out.println hello world. How you are compiling? Java C hello.java. So here you are compiling this code. That means you are saying first you compile it. See, there should not be any kind of syntax error, any kind of error. Runtime error is a different thing. There are two types of error. One is syntax error, another is runtime error. If there is some problem with your logic, that is a different issue. But if there is a problem with your syntax or something, so this will catch all the errors. Okay. So how the bytecode will look like? So this is your bytecode. Okay. So this is your byte. The bytecode, it actually you can understand. So 0, 3, 5, 8. So get static IDC. So you can understand this is intermediate code. This is not a machine code actually. Okay. So if you'll go to that, so what get static means access static field system out. IDC means load a constant hello world. Invoke virtual call a method println and return exit the method. So this kind of information, this is something like this is a bytecode example. If I'll take giving an example of Python bytecode, whenever you will run print hello world, behind the scenes, this is the bytecode will be generated in the PYC file. This is not machine code. This is an intermediate code. It is saying load name, print, load constant hello world, call the function, return the value, right? How, what is the machine code looks like? This is the machine code it looks like. This is the hexadecimal code. Getting my point? This is the code you won't understand. Only the processor or CPU will understand. Are you getting my point? So byte code and machine code differences looks like low level, still readable. Byte code is low level, but it is you can understand it. It is saying that okay, call this one, call that one. But machine code is binary and hexadecimal unreadable. Platform independent. Bytecode means once your bytecode is generated by java.class and something like that. Okay, so you can run it at any platform, either Windows, Linux, anywhere you can run. But machine code you cannot run it in everywhere, right? Because those are specific to the processor. Are you getting my point? Your x86 processor, okay, it cannot be run with the ARM processor. This is the example just now I was just giving the example, right? This example. But this is the binary code example. Here your bytecode is running by the JVM and PVM. JVM is Java Virtual Machine, PVM is Python Virtual Machine. But your machine code is running directly by CPU. Bytecode is an intermediate code, readable, portable, executable by virtual machine. Machine code is the final code that CPU understands. Can you run Java bytecode to anywhere? Yes, absolutely right. You can run everywhere. Java's philosophy, what Java's philosophy is saying that? Java's philosophy is saying that write once, run anywhere. That is Java. That means it is saying if you once written your Java class and it is compiled to a certain intermediate class, you can run it at anywhere. But Python is not possible actually. Python is write once and test everywhere. Are you getting my test means what? Whatever Python file you have written, again you have to interpret whenever you change your platform, it will again you have to write it. Because why? There is a reason. I will tell you why. Because Java is also converted to bytecode, Python is also internally converted to bytecode. Then why you cannot run Python in other environment? Why you will always run the Java in other environment? There is a difference. See, Java bytecode runs on JVM, yes, any operating system JVM. But the thing, Java also converting their code internal to the bytecode, right? Even Python is also converting to the bytecode. But the thing is, that you cannot run .pyc files everywhere because it is this .pyc file cannot support all the files. Suppose you have run the Python with Python 2.7. Suppose you have run something Python 2.7. So internally it is generating this .pyc bytecode. But in your other operating system, if you are running with 3.2, your .pyc, it cannot run. Okay. But there is no problem with the Java bytecode. It can run with anywhere. Okay. Same bytecode on all OS, yes. But here this is version dependent. Which Python version you are using, that is also depending on that. So this is not an ideal choice. Cross-platform support. Build on JVM, this is not by default. Okay, architecture depend. Yes, the Java virtual machine handles it, but this is not guaranteed. Okay, actually, that is another example. Maybe I can just explain to you. Okay, okay, probably I don't know where I have just kept it. Okay, okay, I will go to that later. Okay, Okay, whenever you compile the Java code with Java C, so whenever you are writing a Java code, first we are compiling with Java C hello.java. That means it is generated dot class file containing Java bytecode, not the machine code. That bytecode can run anywhere. That means what? It can run with Windows operating system, Linux operating system, Mac OS operating system, as long as there is a Java virtual machine for that platform. That means what it is saying that if your JVM is installed on Windows, Linux, and Mac OS, your dot class file can run anywhere. But the problem with the PYC file is what? So first of all, this .pyc file has some version dependency are there. Okay, so that is these things you cannot easily run at anywhere. So that is the problem with the Python files is like every time whenever you run that file, okay, so again you have to interpret, again you have to read it, again you have to process it. Getting my point? So this is already I've told you, right? So you have to just compile it, Java C, hello.java. Then you have to dot hello dot. Okay, so that is that distribute the hello dot class and run it everywhere. Once that Java C file, sorry, hello.java is compiled, it will generate a dot class file that is hello.class. Suppose your class name is suppose sarthak.java. So similarly, sarthak.class file will be generated. So you can take that file, okay, maybe through email, maybe through WhatsApp, wherever. Take you to some other platform wherever JVM is installed, it can run it easily. There is no issues with that. But the problem with the PYC is Python's .pyc files are tied to the exact interpreter versions. So if you are run that Python with 3.10 and you will take that intermediate file to some other platform, and if you are running with that file with 3.11 Python version, it won't run. Different platforms or Python versions .pyc may break or can be ignored. Are you getting my point? Your Java C file can run at any platform, but your .pyc might break or can be ignored. That means saying it is not ideal choice to take that .pyc file and run at other platform. Getting my point? So Java bytecode is truly portable. So if you will compare Java bytecode and Python bytecode, so Java bytecode can run anywhere, but Python bytecode may not run. Are you getting my point? Okay. What about PVM? So PVM is nothing but your Python virtual machine. Okay. So the PVM is the component inside the Python interpreter that executes the Python bytecode, compiles your .py file into the PYC bytecodes. This PVM reads and executes the bytecode instruction by instruction. So what Java does actually, Java entirely takes that class file, just compile it and give the result. Here it takes your bytecode, it reads the instruction by instruction. If it finds okay one instruction is wrong with some syntax, it just tell that okay stop the execution. You just fix it, then again you run it. Okay. PVM loads the .pyc bytecode file or compile source code node.pyc exit. Okay. So bytecode PVM loads that .pyc bytecode file. Okay, and try to interpret it. Okay, bytecode interprets. It interprets the bytecode line by line, actually instruction by instruction. Okay, executes the bytecode onto the host machine using the interpreter loop. That is means it is showing, it is telling that whatever intermediate bytecodes are there, okay, on the host machine it is trying to execute by using that Python interpreter. What is the difference between PVM and JVM? JVM means input code is your Java bytecode at dot class file. But PVM means this is Python bytecode, this is dot .pyc file. Execution, this is one very important question. JVM is either interprets or compiles. Okay, but you have to remember always, okay, Java 90% cases it uses compiles the bytecode actually. It doesn't interpret. Okay, but PBM 100% it interprets the bytecode because there is no compiler is available in the C Python. C Python is nothing but the interpreter that it is there in Python. Okay, so this is a program, okay, it is installed in Python. Like this is so this, C Python's work is to interpret your bytecode into the machine code. Performance is faster, obviously, because it is compiling the bytecode. This is a slower because it is interpretation is happening line by line. Bytecode runs on any JVM platform, but bytecode runs on same Python versions only. I told you what's wrong with the .pyc files, right? Complex VM with J8 and optimization, simple VM loop executing the bytecode. It is saying that okay, any complex one, okay, it can implement it, but here it is simpler VM loop executing bytecode. Okay, any suppose I have never used any bytecode for my further use cases. I directly take that file and I run it again. Even if it is becoming slow, that is fine. But I never works with the .pyc files. Getting my point? The PBM is the interpreter inside the C Python that runs on the Python bytecode. Unlike the JVM, the standard PBM does not compile the bytecode into the machine code. Actually, your PBM doesn't compile the bytecode, but one by one, it just interprets it. Okay, that's the reason Python is slower. Okay, but very flexible. Okay, this is the what this is the whole explanation of how it works. But I will tell you one thing. If you will understand this actually, these three things actually, okay, then your all the problems, okay, no need to understand all the things. What is by, are you getting my point? You have to understand how C++ is running, how Java is running, how Python is running. C++ is directly getting converted into machine code. Java is first converting to the bytecode, then bytecode is getting compiled into the machine code. Okay, but here Python code is getting compiled to bytecode, but bytecode is interpreted to machine code. So in your second step, the difference between the Java and Python is Java, you're translating your bytecode to machine code, but Python is translating or interpreting your machine bytecode to machine code. Same thing, your bytecode is converting to 101, 101, 101, but here also becoming 101, 101, 101. Not a problem. But the only problem is here it is at a time it is translating, but here it is translating one by one. That is the reason your interpreted languages are a bit slow compared to the compiled language. Okay, and these are the same thing. It is only just you just giving all the explanation, and I just told you right how the intermediate languages. This is how your bytecode looks like in Python. Here you can understand what it is doing, but machine code you cannot understand at all. Are you getting my point? Any questions?
No, sir.
Any questions, Ravan? Is it confusing?
No, sir, it is not confusing. I just before starting, I just a little bit confused, but now it is clear.
Very simple.
Hmm.
Okay,
Yes.
because you know, see, this is the basics of your Python, how it getting converted and all. Okay, nowhere in your code you will be asked like you write the intermediate code for that. No, nobody will ask you. I am only saying that how internally Python works. If you will see that first three pictures of how C++, how Python, how Java works, then you will easily understand. Okay, no need to go through all those things. But compiles with nothing but the translating that language. In Java and Python, it is translating to the bytecode. Okay, then bytecode in Java, it is getting compiled to the machine code. But in Python, that bytecode is getting interpreted to the machine code. That is the only difference. One is entirely just translating it. Another is one by
Interpret.
one, it is translating. That's the reason it is slow. So
So,
people are saying that Java is a, give me a second. Yeah. Tell me that baby is crying. Okay, tell me. Tell me your question. Somebody was asking something, Shravan.
I'm asking this, you are telling about that ki .pym files. There are issue with the versioning. है ना? So if I am running the Python code which is not running on my
Give me a
machine.
second. Give me. Yes, Shravan, tell me. You are saying something, right? .pyc files.
Yes, sir, I'm asking about the PYC file just like that. I am just running a Python code on my machine,
Huh.
or the then code is giving the some error about the versioning. So
Huh.
how I will know that this issue is coming from the because of the versioning issues?
No. See, the thing is, if you will run that Python code, while running that Python code, it won't give you. It will. What I'm saying is, whenever you run a .py file, a .pyc bytecode gets generated in that same folder or maybe some other working directory. If you will
Hmm.
try to run that .pyc file in your friend system, and your friend system has 3.11, but you are using 3.10, that .pyc won't work there. Are you getting my
Okay.
point? Because
Yes. Yes.
it will
Yes.
say that versioning. Are you getting my point? But in the
Mm-hmm.
Java's case, what Java, once it is compiled to the machine code, you can take
Mm-hmm.
that dot class file and it will give you to the, your friend's computer. If your friend's computer has JVM installed on that machine, he can easily run it.
Mm-hmm.
Generally, nobody uses that .pyc files. Nobody. Everybody runs, take that file, they only run. They don't take the bytecode to run it. Are you getting my point?
Yes. Yes.
Because even if you take that .pyc file, that will also become slow because it will interpret one by one. Na? But in Java's case,
Mm-hmm.
what is happening? If you are taking the dot class file, it will because it is already compiled. So it will very fast. You have to just you can finish it. But even if you take the .pyc file, that won't be that much fast. Then what is the point of taking the .pyc file? Take directly your code and just run it again. Are you getting my point?
Yes. Yes. Yes.
So Python interpreted language means, see, in Java there are two steps are there. You are first compiling it, then you are running it. But Python only
Mm.
one command is there. Python run.py. That's it. You are not compiling
Yes.
separately. Internally,
Mm.
it is compiling and again executing the machine code. But Java, you have to first compile it Java C hello.java. Then you are interpreting. So then again you are running that uh, compiled code. Are you getting my point?
Yes. Sir.
So when you will
Yes.
run it, you will understand. Okay, but you understood the whole concept, yes or no?
Yes.
What
Yes.
is compiling, how Java is working, how Python is working, how C++ is using. Last
Yes.
time I
Yes.
am
Yes.
saying C++ directly it is getting converted to the machine code, which computer can understand. In Java and Python, they are not directly going to the machine code. They are going through a bytecode. In Java, it is that bytecode converting to that machine code by JVM. In Python.pyc is getting converted to the machine code by PVM. Okay, very simple. That's it. Nothing else is there. Compiled is fast than the interpreted language. You have to only understand this many things. That's it. No need to go through how this bytecode looks like. I've just given some extra example. Okay, please go through the video and let me know if any doubts. Okay, we'll meet in the next class. And please get ready
Yes,
for
sir.
question answer sections. Okay.
Sir, tomorrow?
No, I
Yes.
will let you know. Okay. Tomorrow also I have some work.
Oh,
Okay. I will let you know.
okay, sir.